Good morning everyone. Welcome to microwave engineering video series. So in the last 3 classes, we have discussed about E plane T, H plane T, and also we have seen about magic T. In today's video, we are going to see some important points about magic T. Then we are going to discuss about what are the main applications of magic T in communication. So coming to the important points about magic T. In magic T, E arm and H arm are isolated. That means if input is given at port 4, then 0 output or no output at port number 3, and vice versa. Vice versa means if you are giving input at port 3, then no output will be there at port 4 because they are isolated ports. That is the technical word. This is called as isolated ports. And also in case of magic T, because magic T is a 4-port device, so we are going to have port 1, 2, 3 and 4. So 3 and 4 are isolated ports, and also port 1 and port 2 are named as collinear ports. So collinear ports 1 and 2 are also isolated ports. So in magic T, we are having port 1 and port 2 isolated ports, and port 3 and port 4 are also isolated ports. And another important point is, while finding the powers, we can't apply superposition theorem for powers. So for calculating powers, we should consider normalized powers, that is measuring power across 1 ohm impedance. That is, if V1 is equal to A, then normalized power is equal to P1 is equal to A square. That we have discussed and we have seen in the earlier 3 videos. So now we will move ahead with the applications of magic T. The first application is measurement of impedance. Measurement of impedance. That means how to measure impedance by using magic T. That is the first application we are going to see in this particular video. So let's assume, so we have 4 ports here, port 1, port 2, port 3 and port 4 of a magic T. So for port 1, we have connected with a known impedance, that is Z1, that is called a standard variable known impedance Z1 is connected, and at port 2 we have connected Z2. The impedance of this Z2 is unknown impedance, okay, and across port 4 we have connected a null detector, and across port 3 we have connected a microwave source. So altogether we are having 2 impedances connected to port 1 and port 2. Port 1 impedance is known impedance, which is a variable impedance, and port 2 is unknown impedance, and port 3 is microwave source, and port 4 is null detector. So we are going to measure the impedance of this Z2, which is unknown, by using this particular magic T. So this look like a bridge. So unknown impedance can be measured using magic T in the form of a bridge, okay. So for this particular magic T, the input will be from microwave source. So the input from microwave source, so let's assume A3 is the input signal, that is A3, which is coming from the source, that is microwave source at port 3. The input from microwave source A3 gets divided between port 1 and 2. So this we have seen the property. When we are having input at port 3, the output we are going to get it across port 1 and 2. The amount of output you are going to get is, that is by root 2, A3 by root 2, because this is a signal. If you look at the power values, what you are going to get, A3 square by 4, because P is equal to A square. So in this case, A is A3 by root 2. We are going to get A3 square by 2, that is half of the A3, right? So from this source, you are going to get a signal that is going to be divided into port 1 and port 2 equally, A3 by root 2, A3 by root 2. So this signal or power is going towards port 1 and this is going towards port 2 because the impedances are not equal to characteristic impedance. So there will be reflections from port 1 and 2 because the impedances that we have connected at port 1, that is Z1, and at port 2, that is Z2, they are not equal to characteristic impedance Z0. So there is a possibility of reflections coming from each port. That means this particular arrow mark indicates the reflected power, and this is the reflected power coming from port 2, and this one is from port 1. So again this will be A3 by root 2 into rho 1. Let's assume rho 1 is our reflection, rho 1 from port 1, and rho 2 is the reflection coming from port 2. So this is A3 by root 2 into rho 1. This is A3 by root 2 into rho 2. So these two are going to meet at the junction and they are going to travel towards the null detector. So in this case, so this A3 by root 2 into rho 1 is going to again split into halves. So here 1 by root 2 into A3 by root 2 rho 1, here minus 1 by root 2 into A3 by root 2 into rho 2. So the resultant wave in the null detector means at port 4, that is E arm. This minus sign we are getting because of the E arm. In case of H arm, we are going to have a in phase. In case of the E arm, we are going to have a out of the phase. So the resultant wave in null detector at port 4, we can write as 1 by root 2. This is 1 by root 2, A3 by root 2 into rho 1. And also this one also coming from the port 2, right? That is minus 1 by root 2 into A3 by root 2 rho 2. So if we write this, so we can simplify and we can take A3 common, then we are going to get A3 by 2 into, that is rho 2 into rho 2 is 2. So A3 by 2 into rho 1 minus rho 2. So for getting the balancing of the bridge, what has to be done? This equation should be equal to 0. That means if equation 1 is equal to 0, then we are going to get rho 1 is equal to rho 2. So rho 1 and rho 2 can be written as in terms of characteristic impedance as Z1 minus Z0 divided by Z1 plus Z0 is equal to Z2 minus Z0 by Z2 plus Z0. Basically rho 1 is the reflection coming from Z1. That's why in this particular formula we are having Z1 minus characteristic impedance divided by Z1 plus characteristic impedance, and this rho 2 is coming from the unknown impedance, that is Z2. That's why in the formula we are having Z2 minus Z0 by Z2 plus Z0. If you simplify this, we are going to have Z1 is equal to Z2. That means when the impedances of Z1 at port 1 will matches with impedance at port 2, that is Z2, then this detector is going to show you a null. That is how we are going to measure the impedance. That means till it is going to show the null value, we are going to vary the known impedance value. Thereby we are going to measure an unknown impedance by using the magic T. So very useful. So unknown impedance can be measured by adjusting port 1. Adjusting port 1 is what? Adjusting the known impedance value, because it's a variable impedance. So we can vary this Z1 value till we are going to get, till the bridge is balanced and both impedances becomes equal. That means if it is balanced means what? Whatever the impedance we are getting here, if that is equal to Z2, then only bridge is going to balance. So in that way, this Z2 value can be calculated by using this particular configuration, that is measurement of impedance by using magic T. And the second application of this particular magic T is magic T can be used as a duplexer. So here we can see the arrangement. Again we are having 4 ports. Port number 1, this is port number 1 connected to transmitter, and port number 2 to receiver, and port number 3 to H arm. Basically this is H arm for magic T, which was connected with a matched load. Okay, and port number 4, this one is connected to antenna. That means basically port 4 is E arm. That E arm is connected with an antenna. Port 3 is your H arm, that is connected with a matched load, this matched load will absorb the entire power which is coming toward this particular port. That is a property of the matched load. Okay, and port 1 transmitter, port 2 receiver. In case of magic T, port 1 and 2 are isolated and port 3 and 4 are isolated. So this we have discussed in the previous discussion. Okay, so here from port 1, basically this is a transmitter. So from the transmitter we are going to have the power. So this power is going to be towards port 1, port 3 and port 4, because 1 and 2 are isolated ports, so nothing will go towards port number 2. So whatever the power is there at port 1, given at port 1, that is going to be divided into 2 halves and going to be there at port 4 and port 3. That is, from port 1, half power goes to port 4, that is antenna, and other half absorbed by the port 3. Absorbed by port 3 means what? The power which is coming, half power, towards this port 3, that is going to be absorbed by the port 3, because we are connected a matched load. That is matched load without any reflections. The main task is it absorbs the power without any reflections. Okay, that is the thing. Then whatever the half power reached to the antenna, that will take as a input for this antenna, and antenna is going to give the output, and that output is going to be half of the received power will go to port 2 and other half to port 1. That means in this case, this port number 4 is going to act as an input. From where it is going to get the input? From the antenna output, because antenna has taken an input from the transmitter, and from the transmitter input, antenna is going to give you output. That output is going to act as a fourth port input in this way. So in this case, so since if you are giving port 4 input, then port 4 and port 3 are isolated ports, then nothing will come towards port 3, but the power is going to be distributed into 2 halves across port 1 and port 2. That means, so we will go to port 2 as well as it is other half is going to port 1. So in the entire process, we can observe both the transmitter and receiver are isolated. Both the transmitter and receiver are isolated. That means both are isolated, because port 1 we have connected transmitter and port 2 we have connected with receiver. So in case of magic T, we are using the property of isolated ports, that is port 1 and 2 and port 3 and 4. By using that particular property, we are going to have this particular magic T as a duplexer. That is very, very important. In the entire process of our discussion, both the transmitter and receiver are isolated. That is very, very important. So we can use a magic T as a duplexer. That is the second application of magic T. And coming to the third application of magic T, so we can use magic T as a mixer. Okay, so let's see the diagram or configuration of the magic T. So magic T means 4 ports, right? So it's a 4-ported device. So port 1, so we are connected a mixer. Port 4 is our E-arm, that is connected with an antenna, and port 3 is a H-arm that we are connecting with a local oscillator, and port 2 with a matched load. Matched load means it will absorb the power without any reflection, that is zero reflected power. That is a property of the matched load. Okay, so here what we are going to get, so this magic T can be used in receivers as a mixer by giving one input at port 4. One input at port 4 means this antenna will give you an input that will be at port 4, that is antenna at E-arm, and at port 3 we are connecting a local oscillator. So local oscillator also will give you the input. So we are going to have an F0 frequency input from local oscillator, and we are going to have a F1 frequency from the antenna. So at port 1, what is going to happen? At port 1, so we are going to have whatever the input you are giving. So please remember, this input is going to be divided into the other 2 ports equally. Okay, half power is going to be there. So at port 1, half power from local oscillator, means whatever the power is coming from local oscillator, only half will be there at port number 1, that is towards mixer, and half from the antennas. Antenna means fourth port. From the fourth port also we are connecting input. So the half power will also be there towards the mixer, and this goes to mixer and generate a intermediate frequency. That means F1 and F2 are F1 and F0 we are going to get. Then intermediate frequency is nothing but F1 minus F0. So likewise, so here, and one more thing, the power, half power from coming from the antenna is going towards this way, and other half is going towards this way. So in this case, that is port number 2. Port number 2 is connected with a match load, so there won't be any reflections, complete absorption. Okay. Similarly, from local oscillator, you are going to have a 2 parts of power. One half this way, other half this way. This half is going to be absorbed by this particular matched load. Okay. So we are going to receive here half of the power from antenna and half of the power from local oscillator, and both are going to mix it, and you are going to have a intermediate frequency, that is F1 minus F0. So this is the one of the important application of magic T. So we can use magic T as a mixer, and we can use magic T as a duplexer, and we can use magic T for measuring the unknown impedance. So these are the some of the applications of magic T which we have discussed in this today's video. Okay, so in the next video we are going to discuss one more junction, that is called as a rat race junction or hybrid ring, that we are going to discuss in the next video. Okay, thank you. Have a nice day.